Hello everyone. So today we are going to learn about tests of statistical significance. So why do we need these tests? So let's suppose you have a hypothesis that boys on average are taller than girls. So to test your hypothesis, you take a sample of 200 people, and out of 200 of these people, 100 are girls and 100 are boys. And at the end of your study, you conclude that the average height of girls is 5 feet and the average height of boys is 6 feet. And you go to your friends and you tell them these results, and they say that these results are a fluke and no such thing actually occurs in reality. So how do you prove to them statistically that this is not a fluke and such difference actually occurs? So one way is that you go out and you take the height of every single girl and every single boy. So that would be 8 billion measurements. And at the end, you can say for sure that boys are taller than girls. Or there is another method. You can actually apply a test of statistical significance. So for this study, we will apply a test called as t-test. An unpaired t-test would be applied and it will give us a p-value. And if our p-value is small enough, we can statistically conclude that these results are actually statistically significant and such difference actually occurs in reality. So what is a p-value? A p-value is probability of obtaining results as extreme or more extreme than observed, assuming that null hypothesis is true. So what does that mean? That if we assume that there is no difference between height of girls and boys, and then we measure their heights, what are the chances that results as extreme as ours, which are in our case is a difference of 1 feet? So what are the chances that a difference of at least 1 foot would come by chance? So that is our p-value, and this is measured by tests of statistical significance. So at what p-value do we consider that the test our results are statistically significant? That is determined by our preset alpha. So alpha is a threshold we set before the study. So this is the difference. Alpha is set before the study, p-value is measured after applying the test of statistical significance on our results. Okay, so alpha is, think of it as level of strictness. So it is the amount, the probability of type 1 error that we are willing to allow. So what is a type 1 error? Is actually false positive rate, which means that if null hypothesis is true and we falsely reject it and we consider it the results as true or positive, that probability is known as type 1. That error is known as type 1 error, and the probability that we are willing to allow for that kind of error to occur, that is called as an alpha. So if our p-value is greater than alpha, that means that the null hypothesis is failed to be rejected, and if the p-value is smaller than alpha, that means that we can statistically reject the null hypothesis and our results are statistically significant. Okay, so now we have to decide what kind of test would we apply on a given set of data. So before jumping into that, we need to know there are two types of variables. There are quantitative variables and qualitative variables. Qualitative variables are also called as categorical variables. Quantitative variables are also called as numerical variables. So I like to think of them as quantitative variables as like scale variables. So these are the variables that you measure and they are continuous. Like the possible values are coming in a continuous manner one after one. Like let's say height. So height can be 10 centimeter, 10.1 centimeter, 10.2 centimeter, 10.3 centimeter, or you can go even more specific and then we can go 10.11 centimeter, 10.112 centimeter. So we can go more and more precise in these measurements. Same goes for height, same goes for weight, same goes for blood pressure. Okay. And then there are qualitative variables that I kind of think of them as bucket variables. So these are like categories, these are buckets, and then these variables can go into these different buckets. So let's say we are thinking about gender. So gender can go into two buckets, either male or female. Blood group, it can go into A bucket or bucket B or bucket AB or bucket O. Okay, depending upon the type of these variables, we apply different tests of statistical significance. So if both of our variables are categorical or both of our variables are bucket variables, then we apply chi-square test. So let's put that in an example. So we are trying to determine the correlation between smoking and lung cancer. So one of our variables is smoking status. So a person can be a smoker and a non-smoker, and another variable is cancer. So a person can have cancer or don't have cancer. Okay, so these are two possible. So there are limited number of options in these bucket variables or qualitative variables or categorical variables, and these are the variables for which you can make this 2 by 2 or 2 by 3 or these tables. Okay, so as I made a table here for smoking and cancer. Okay, so a person with cancer and he smokes, let's say 10 of these people, there are 5 of these people, there are 1 of these people, 9 of these people. Okay, so we can make a table for these variables. Okay, and for these kind of variables we do a chi-square test. So when both of the variables are qualitative or bucket variables. But if one of the variable is a qualitative variable and the other variable is a quantitative variable, so let's think of it as our primary example where we said that the difference between height of boys and girls. So the gender itself is a qualitative variable. So there are two buckets here, a male bucket and a female bucket. But height, on the other hand, is a quantitative variable. It can be measured on a scale. It is continuous. Okay. So we take a mean of the height. We can't take a mean of gender. Okay. So you can take the mean of quantitative variables. You can't take mean of qualitative variables. So for height, our mean was 6 feet for boys, 5 feet for girls. So these are two means. And to measure the difference statistical importance statistically to measure if these difference in means are statistically significant or not, we do t-test. Okay, so if there are two subcategories in categorical variables, or if there are two means, so in this condition, in this particular example, there are two means. 6 feet is a mean for males and 5 feet is a mean for females. If that's the case, then we apply a t-test. But if there are more than two means, like if we are measuring the height of different nationalities, so there are Americans, there are British, and there are Canadians, okay, and their height difference, we take the mean of their heights, and then we have to apply a t-test, sorry, a test of statistical significance. That won't be a t-test, that would be an ANOVA test. Okay, so how I remember it is that ANOVA has three variables, ANOVA, so ANOVA is three. So if there are three or more of these means, then we apply an ANOVA test, and if there are two of these means, we apply a t-test. A t-test can be a paired t-test or an unpaired t-test. A paired t-test is applied when there is only one categorical variable, but that categorical variable, the quantitative or continuous variable for that categorical variable is measured at different times, or before or after an event. So take an example that we are measuring the blood sugar of 100 diabetic patients before they have breakfast and after they have breakfast. So the group of people are same, they are 100 diabetics, but we are taking their blood pressure in relation to doing breakfast, so before breakfast and after breakfast, and that would be a paired t-test. So they are paired with themselves. That's how I remember it, that they are paired with themselves in relation to an event. But if there are two different group of people, like male and female, and we have to compare their means, then we apply an unpaired t-test. Okay, so